DevOps alerts fail in two ways. There are too many and they are missing context. Each time you receive an alert, you still have to ask, is it Kubernetes, a bad deployment, a pod crash, or is it my Grafana query? So you start jumping between dashboard, logs, documentation, Slack, and many more. One day I was like, right now that we have MCPs for almost everything, why I don't simply let AI investigate my alerts? So I did it, and it's working great. In this video we will explore what is an MCP and how we can use them to solve real problems. I deployed an application in Kubernetes that is generating metrics and logs. This application is being monitored using an observability stack. We are going to simulate some incidents and see in real time how our AI DevOps investigator will use different MCPs to troubleshoot each alert. My name is Diego. I'm a network and systems engineer based in Paris, and I like breaking down tech concepts into simple and visual explanations. Thanks to Docker for sponsoring today's video. If you want to see more videos like this one, feel free to subscribe. And that's all. Back to the video. If we want our AI to troubleshoot something, first we needed something to troubleshoot. I built an application and deployed it in Kubernetes. My application is a hoodie store. By the way, you get 20% of discount if you subscribe. This application is built around something called OpenTelemetry. OpenTelemetry basically lets you generate and export metrics, traces, and logs so that you can monitor your application. Another feature of our store is that we can trigger incidents. If we trigger an incident, the status of our store changes to incident active. This is going to generate some errors inside the application and create latency spikes. But we are not done yet. We need to actually monitor this. I have set up the standard observability environment using 3 containers. Prometheus, which scrapes and collects the metrics, Loki, which collects the logs, and the third one is Grafana, where I connected the first two to visualize those metrics and logs. Here, I built a cool dashboard to monitor our store, where we can see stuff like uptime, requests per second, and the store's latency. We can even see how many sales I have made. Also, we can see the error rate. This one is super important. So for that one, I have some thresholds. If the errors increase, those thresholds are going to trigger some alerts. If I scroll down, we can also see the logs of our application. Let's start putting some MCPs on the table. For those who are new to the subject, MCP stands for Model Context Protocol. MCP is the current standard that AI tools use to communicate with external applications and services. It is like giving ChatGPT the power to control your Notion, for example. This integration is divided in 2 sides, the MCP server and the MCP client. In our example, the MCP server will be the Notion MCP server, and the MCP client can be an AI tool like ChatGPT. Right now, the most common MCP client is Claude, because it is really easy to set up. The MCP server exposes a set of functions that the MCP client can use. In our example, the Notion MCP server will probably provide functions like create new page, search for content, add comment, and so on. Now it is way more clear what we are trying to do. We are going to connect our Kubernetes cluster and Grafana instance using MCP servers, so that our AI will be able to investigate alerts by using functions like checking dashboards, querying metrics, and reading logs. However, there is a big issue when implementing MCPs. Let's imagine we want to set up Claude to communicate with our Grafana MCP server. First, we need to Google the MCP server to find its documentation. Then we have to understand the setup process. And finally, we have to connect everything manually so that Claude can recognize it as a new integration. So if you want to integrate, let's say, 7 MCP servers, you end up repeating that same process 7 times. And on top of that, you also have to manage credentials that are often in plain text. Now the good news. Docker solved these issues by implementing something called the MCP Toolkit. The idea is simple. If we can run applications inside containers, why not also run MCP servers inside containers? The MCP Toolkit is made of 3 components: the MCP catalog, the MCP servers, and the MCP gateway. The MCP catalog is a list of all available MCP servers that you can choose from. Once you find the one you want, you just click on Add MCP Server, and Docker adds it to your system automatically. You only need to provide a few requirements, like your Grafana URL and your Grafana API key. So even your credentials are managed in one place, instead of being stored as plain text in config files. And then the last piece is the MCP gateway. Instead of adding 7 different integrations in Claude, you just add one, your Docker MCP gateway. And that single integration allows the AI to communicate with all the MCP servers that are behind. If you want to experiment with MCPs, this is the easiest and more secure way to do it right now. Basically, in Docker Desktop, now you have Kubernetes, containers, and MCPs. And by the way, all this, it's free. I will leave the link in the description for Docker Desktop if you want to give it a try. And of course, you support the channel by doing it. So now we have our 2 MCP servers up and running. And if everything is well set up, we can now do a small test on Claude and tell, can you please list my Grafana dashboards? Now he is basically asking permission to perform this action. He's saying, I found 2 Grafana dashboards in your Grafana instance, my hoodie store dashboard that is indeed the one I built, and alerts, that is a folder containing the alerts of this dashboard. And that's pretty cool. Now let's test the Kubernetes MCP server. Can you tell me if there are any issues with the pods of my hoodie store? And we don't even need to tell Claude which MCP server to use. It automatically understands that this is a Kubernetes question and decides which is the best MCP server to use. As we can see, it gathered all the information: the name of the pod, the namespace where it is running, the status, when it was created. So instead of manually checking events, logs, and restarts, we can simply ask in natural language, and the AI will generate a full investigation report for us. And you can tell that it is already working great. However, there is one limitation with this approach. It only works if everyone on the team has Claude installed. So what about relying on a tool that everyone is already using, like Slack or Microsoft Teams? So I built a Slack bot that is connected to an MCP client. This means that everyone on the team can interact with our MCP servers directly from Slack. For example, we can say, MCP, can you check if there are any ongoing latency issues in our store? Customers are complaining. The cool part is that he is smart enough to say, I already gathered enough information, now I can reply to the question. Okay, so he just replied. He did a latency check for the last 30 minutes, and he's saying that my hoodie store is under 1 millisecond. That this is very low. There is no clear sign for latency spikes, mainly because we didn't trigger any incident, like the store is really stable right now. And we can keep discussing and he's going to keep the context of this conversation. Okay, so with this we improved the design a lot. But the real goal was even bigger. The beginning of this story was, we receive a lot of alerts, how we can get someone to investigate them automatically. And that was the next step. Now every time Grafana sends an alert, it automatically triggers our AI DevOps investigator. Let's do a quick example. Let's trigger an incident in our hoodie store. We will see how the latency and the error percentage starts increasing. Okay, we just received the alert, and the MCP bot already replied. Is doing its investigation. He is saying the 500 responses increased from 0% to 1.2% over the last 5 minutes. He's also saying there is only one pod for the hoodie store running, with the restart count 2. In the suspected cause, he's saying the primary cause can be that as we have one single pod in best effort, there can be too much pressure and this can be leading to the kill restart and generating the 500x responses. And that's it. We basically have a DevOps agent that can investigate every alert we receive from now on. Let's look at our final architecture. This implementation was simple because we could centralize our MCP servers using the Docker MCP Toolkit. MCPs are a popular subject right now. Everyone is trying to explore them and see what we can build with them. But I think we should look at this from the opposite direction. Let's look at the problems we already have and try to solve them using MCPs. I hope this video gave you a clear view of what is an MCP and how we can use them to solve real problems. If that's the case, give me some feedback in the comments. I will appreciate it. Thanks for watching and see you in the next one.